Welcome back to Ali Khan Maths. In this video I'm going to be going through some exam questions for the circle theorems. These questions are all taken from real past papers and will showcase a variety of difficulties, so you'll see the easiest and the hardest types of questions that you'll come up against during an exam. If you need to brush up on your circle theorems knowledge, click the playlist in the description down below to watch my first 3 videos covering the circle theorems in depth. You can share this video, subscribe to my channel, and make sure to leave a comment with any feedback or requests for specific topics or questions. This first question is likely one of the easier questions that you'll find on circle theorems in an exam. It says that A, B, C, and D are points on the circumference of a circle, with some lines drawn between them. We're told that angle CAD is 62 degrees, and angle ADB is 51 degrees, and we're asked to find the size of the angle ACB, which is this angle that we'll mark in. The angle ADB is formed from two lines which extend from the points A and the points B, this line over here, and this line over here, and the angle between them is 51 degrees. Angle ACB, similarly, is also formed from lines coming from those 2 points. A line stretches from A to C, and a line stretches from B to C. This means that the angles are subtended by the same points, and they're located on the same arc over here. This means that angle ADB is equal to angle ACB, so it's also 51 degrees. The second part of this question says to give a reason for your answer, which is worth 1 mark. This is what we just said, that angles subtended by the same arc are equal. You must make sure to write the full name of the rule in this question to get the mark. This next question is slightly more difficult. It says that B and C are points on a circle with a center O. It's drawn in the tangents AB and AC, and we're told that they are tangents, and told that angle BAC is equal to 40 degrees, so we'll mark that in. We're asked to work out the size of angle BOC, and of course that we must show all our working. Angle BOC isn't actually drawn in for us, so we'll have to make a few construction lines to make it ourselves. So first we're drawing the lines OB and OC. Since they're both lines which come from the center to the circumference, they're radii of the circle. We are told in the question that AB and AC are tangents to the circle. Next, remember that when a radius meets a tangent, the angle formed is 90 degrees. Here we've got 2 radii, meaning 2 tangents, so these angles are both 90-degree right angles. Finally, to work out angle BOC, you must notice that we formed a quadrilateral here, a kite to be precise, with the 4 sides OB, OC, AC, and AB. The angles in a quadrilateral sum to 360 degrees. Here we've got 3 angles in a quadrilateral and 1 missing angle BOC, and all of these together must sum to 360. This means that angle BOC plus 220, which is the sum of these 3 angles, must equal 360. To get BOC on its own, we subtract 220 from both sides to find that angle BOC is equal to 140 degrees. That's our final answer. This final question is one of the harder problems that you're likely to encounter at GCSE level. We're given points CDE on a circle, which are joined together to form a triangle, and the circle has a center O. Line AEB is a tangent to the circle, and the point of tangency is point E. CD is equal to DE, and angle AEC is equal to X, so we'll mark that in. We're asked to find the size of angle OED in terms of X. Since we have an angle formed between an inscribed triangle and the tangent, we can use the alternate segment theorem here. This means that angle AEC, X, is also equal to angle ADC, which is the opposite angle in the triangle, so this is also equal to X. And the triangle has 2 equal sides. That means this triangle is isosceles. Next, we'll introduce another variable which will make some of the equations a little bit more easier for us. We'll let y equal angle DCE, which is this angle over here. Since we've shown that this triangle is isosceles, that means its base angles are equal. So this angle DCE is equal to this angle CED. So we can mark that in here as well. Remember to write in your reasoning for each step here, since we're told to give reasons for each stage of your working, and this can form much of the marks given to the question. Since these angles are both equal to y, we can write that 2y plus x is equal to 180, because the angles in a triangle sum to 180 degrees. And then we can rearrange this to make y the subject of this equation. Subtract x from both sides, and then divide by 2, to get that y is equal to 180 minus x all over 2. Remember that y is equal to angle CED, so that means this whole angle here is equal to 180 minus x over 2. We'll at the start of the question that the line AEB is a tangent, and the line OE is a line which goes from the center to the point of tangency. This means that this line OE is a radius. Remember that when a radius meets a tangent, the angle formed is 90 degrees. So this whole angle here, OEA, is equal to 90 degrees. Angle CEA is equal to x, and the whole angle is 90, which means that this angle OEC has to equal 90 minus x. To go over that again, since we have x over here, and the whole angle is 90, this means that this must be 90 minus x, because these two add together to give 90. Remember that we're trying to work out angle OED, which is this little angle over here. We can find angle OED by taking the big angle of this triangle, which is angle CED, and subtracting this little angle OEC to leave us with just the part that we need. We've already worked out these two angles. We worked out y, which is equal to CED, and OEC, which is equal to 90 minus x. So we can substitute in the expressions we have for these to see what our answer is. We have 180 minus x all over 2 minus angle OEC, which is 90 minus x. We can rewrite this in fraction form to make the subtraction easier. So we're left with 180 minus x over 2 minus 180 minus 2x over 2. Once you complete all the subtraction, you're left with x over 2, which can also be written as a half x. Since our answer OED is going to be in terms of x, we can leave it as this. Without forgetting the degree symbol, because OED is an angle, this is our final answer. Remember to leave a like and subscribe and share this video with anybody who you think might need it. Thank you so much for watching.